Hey everyone, it's Ben with Arctic Cat, and in this series we are diving deep into the engineering world and specifically catalyst. In this episode, we are going to be talking about the chassis and body plastics. So joining me here today is David. David, thanks for joining us.
Thank you, thanks for having me.
So Dave, the catalyst is really a one chassis design that's applicable for the trail, the crossover, and the mountain segment. Shouldn't it really be three different chassis designs?
Well, we started off, we were looking at different ways of commonizing, and everything started falling into place where things were getting close. So we worked hard to make it combined and use one part. So we're sharing tooling on all these parts across the entire family.
Tell me, what are the differences that we see between the different platforms, the three different segments that we have?
The big ones are steering mounting, was shared on this frame, and track drive location, which is key for mountain, the trail, and the crossover. They all want different approach angles with their skids, so we have the different track drive locations, and that's what pretty much sets the frame apart to the chassis.
So there's one core design, but small modifications that are made to fit each different segment.
Yeah, and that all comes in the mounting. The mountings they're different mounting positions for those systems.
So the belt drive is oriented differently for the trail, crossover, and mountain segments? Correct.
And you can see that on this plate here, there's multiple holes, and 3 holes mount the belt in different orientations. And trails it's up and back, and our mountains are down and forward.
So when we talk about the catalyst platform, the topic of mass centralization and low center of gravity is really at the core of everything. And we talked already about the laydown engine design. What other components are, designed around this platform that help with that low center of gravity and mass centralization?
So the motor moved in our layout to start, and we were trying to get it down as far as we could, and we got it down there, but we had all these other loose systems that weren't tied together. So we made a decision up front. We always had the TCL, which joined our clutches, but we were going to make a pipe mount too that goes on top of it. So it's a clutch guard / TCL, and that allows the pipe to move with the whole motor, and it also takes all the weight down with it, so it all moves together. Our clutches, our pipe, our motor, all of it went together, shoving it down, which also drove into location of some of our frame members too. Like our upper A-arms went down, shortening our spindles. I mean, everything was starting to get down, roughly 2 inches, everything was moved down. And it's been a huge improvement to the sled.
So what is the rider experience when they have that centralized mass and lower center of gravity?
The sled's already lighter by nature, but with everything moved down, it's even more of a drastic ratio to our weight and our CG, making it even more maneuverable than we've had in the past.
So the front frame is one piece constructed out of an ultra high strength steel. Tell me a little bit more about what I'm looking at here.
So over the course of all of our prototype builds and into production, we have totally evolved this thing into what it is right here. The first ones were stampings and tubes just to learn in the field, get some load data. And then we've evolved piece by piece to optimize diameters, thicknesses, materials, and the castings evolved from highest loads from steering, top and bottom, and our shock loads into our frame. And a lot of time has been spent designing these and creating them to mitigate all the loads we're seeing.
And I'm noticing there's no fasteners on this as well, and I assume that increases strength and rigidity as well?
The rest of the industry is using a lot of fasteners on their spars and their joints, and over time they will loosen up, and then the whole top structure starts getting loose, and you can have failures down the road from that.
So this is an industry first to have a one-piece, high-strength front end?
Correct, top to bottom. In the past we've had some other sleds that had just bottom portions, but never had the top connected to it as one piece.
Wow, that's pretty cool. And I assume less joints, less fasteners, less weight as well.
Correct.
So the goals for Catalyst were to be the lightest in the industry, but not sacrifice any of the strength and durability that Arctic Cat's really been known for. Did we succeed in doing that?
I believe so. With the rigidity of the front end, and even everything down to our rivet joints from our tunnel to our heat exchanger, those have all been analyzed and optimized for strength.
Now, I want to move to the running boards. This is something that is obviously pretty eye-catching when you first look at this sled, and it's totally new. Can you tell me a little bit about what we're looking at?
So it's a composite running board. It's fiberglass reinforced. The direction to go on it was we wanted something that would shed snow. It wouldn't pack snow, and we wanted certain windows, which we're kind of limited with our stampings like we use now, and same with tubes. This allowed us to design in decorative tread features and also put the structure where we need it for not only our foot, but for some of the chassis loads it's seeing too.
So when you mentioned the running boards, you talked about a long fiber composite material, and this isn't just plastic. Tell me a little bit more about what this is.
It's a highly engineered glass reinforced nylon that we used in the past on similar components like the TCL plate. And that has kind of led us into looking at this on our other parts, the running boards, the toe stops, rear kick up, and the taillight housing. Now their blends are a little bit different based on their loads and the kind of flex we want to see out of them too.
So we're not just seeing these on the running boards, there's other components that are incorporating this long fiber composite.
Correct. That way we get kind of the same style look to them, just to kind of tie everything together, and it also takes up a lot of the loads we're seeing on chassis.
So the Catalyst employs an all new tapered one-piece tunnel. Can you tell me about some of the benefits that we get out of this design?
So by making it one piece, we've eliminated some fastening joints, and it just makes it's just stronger as one piece than having a joint that can loosen up over time.
And the attachment of this tunnel to the frame itself is different as well, is that right?
Correct. So our heat exchanger goes in with the tunnel assembled to it, but if you have any damage to it, there's a rivet line on the back side of the heat exchanger, a couple of bolts up top, and without dropping anything else, you can slide the tunnel at the back. So the heat exchanger is mounted to it, but it can stay behind on any kind of repair. And the heat exchanger is actually the backbone to this whole sled. The frame slips over it, the tunnel slips over it, and that is the backbone of the sled.
So speaking of the heat exchanger a little bit more, it's a new one-piece weldment design. Can you tell me a little bit of the benefits that we get out of that?
So with the one-piece heat exchanger, it's less joints, so we have to seal with a fastener or a hose clamp or a hose. We have multiple lengths for different segments. We have the short mountain, a medium length crossover, and then we have the longer trail. Each of those have their own track drive location, which when married to this chassis, lines up on that side for mounting brake disc and your track drive. And that's what sets up the unique chassis on all the sleds.
So we have another episode dedicated just to accessories, but I want to talk a little bit about the storage capacity and the ease of access when we're talking about the Catalyst platform.
Yeah, so the suspension brackets and running board mounts are one big bracket that actually carry up the sidewall of the tunnel, and the attach system actually fastens to that, and that takes all the load of our two-up seat, our fuel tanks, our Pelican boxes, all that.
So there's some structural rigidity that's added by even having that attached system.
Correct, and that load path is directed down to the rear arm where we box in with our rear arm of our skid, and everything's tied into the running board edge tube, the rear kick-up, and the running board.
Now bringing it back up to the front of the sled, there's also some more storage capability obviously up in the handlebar area, and then there's also a lot of ease of access with these body panels and hood. Can you talk to me about that as well?
Correct, yeah, we've got the storage box up in front of the handlebars where you can put goggles, gloves, face mask, random things. And then we have quarter turns that remove our side panels, and we have a new hood latch that is similar to our seat latches off of other products we've used in the past. And it's a one-pin system that pops the whole hood off.
So having basically toolless body panel and hood removal, you're increasing the ability to service and maintain your vehicle as well.
Correct, and it's easy to get to the underside of the hood because underneath our headlight there's a little compartment that holds our spare belt. So it's easy to take off, easy to get to your belt when you need it, and your belt's always warm and ready to operate.
Now, speaking a little bit more about the body plastics, obviously when you look at the design of the Catalyst, it's very unique. Everything looks very compact. Was there a reason behind that? Or tell me a little bit more about the engineering that went into the body plastics themselves.
So we've combined our bottom of our airbox with our hood to make it not just stylish, but functional for other systems like our air intake. Our side panels are positioned for looks and to be as narrow as we can, nesting it as tight as we can to every component on there. We're not going to get to as narrow as a dirt bike, but we're trying to get there, and everybody is too. Everybody's trending that way. And we're getting closer and closer, packaging everything as tight as we can.
Now, when we talk about mountain riders, they're some of the most active when we talk about rider input. Let's talk a little bit about what makes the Catalyst a really rider-centric design.
The lower CG has helped every segment, but probably more so the mountain, making that thing side hill like no other sled. It's flickable, it's fun, and it is very agile in those environments.
So again, we bring it always back to the mass centralization, the lightweight, and the low center of gravity. And one thing that comes to mind for me is fluids and the tremendous amount of weight that we're carrying around. Can you tell me about what we've done with the catalyst to improve that?
So on our past models, our oil volume has been here on the right side behind the exhaust. We've actually centered it at and put it more centered on the sled. We don't have to worry about intakes or exhaust in the backs of our chassis. So we're able to lower our tank and push the fluid down closer to the tunnel, which is helping our CG also on this sled.
So centered, tight, and low. Those are the three keywords that we're talking about when we talk about catalysts.
They are key.
Well, excellent. Well, Dave, thanks so much for joining us today. If you guys want to learn more about the catalyst, visit articat.com/catalyst.